Hello, hi. Now I'm going to discuss about D flip-flop. So already we have seen that SR flip-flop. So here in D flip-flop, if you see that what we have done, this the D is the single input here. So that D is connected to the NAND gate 1 and complement of D is connected to the NAND gate 2. And in case of flip-flop, we know that clock is must. And here we are considering the positive edge trigger since flip-flop is the 1 bit storage edge trigger device. So here we are considering that when this clock pulse is changing from 0 to 1 that we call as the positive edge trigger, then only this device is going to trigger. After that, only if input is available, device is going to response for that particular inputs. So now here in the case of flip-flop, two things is important. One is the truth table, second one is the excitation table. So these two are must whenever we are going to discuss about flip-flop and later when we are seeing the conversion where we are going to design one flip-flop with the help of another flip-flop, there also it is very important. So now in this case, since we are considering positive edge trigger, when you're changing from 0 to 1, so that time clock pulse is going to be here, that value will be what? 1. It is transition. Suddenly is going to change from low to high. So high we are considering as the 1. And here in the initial, we are giving D as the 0. So that 0 will be available as the one of the input to the NAND gate 1. And for the NAND gate 2, input will be available due to D is that is the 1. Now, since clock pulse is already 1, so NAND gate 1 output will be 1. And NAND gate 2 output will be 0. Now, from the NAND gate truth table, we know that if any input is 0, output will be high. So on the basis of that, we are going to see the operation of the latch. So this cross-coupled NAND gate 3 and 4 is forming here latch combination. So whenever we are going to design the flip-flop, so latch is the basic buildings for the flip-flops. So now since one of the input is 0 to the NAND gate 4, so output is what here? It is the 1. Now the same Q dash is given one of the input to the NAND gate 3. So NAND gate 3 having both input as the 1. So output of the NAND gate is 0. So that Q become here 0. And already we know that D is the transparent latch or flip-flop. So whatever is available as the D, that is only going to available in the output also. So when we are going to check the next state condition, what will be the next state if input remains same as the 0? So that again we can verify here. Now this 0 is going to be that is the Q was the 0 here, that is going to become one of the input to the NAND gate 4. So both inputs are 0, so output is going to become 1. Now this Q dash is going to become another input to the NAND gate 3. So already here we have 1. Now this is also 1. So finally output of the NAND gate is 0. So there is the no change in the output. So that's why if you see here in this condition, when D is 0, then we have either Qn is 0 or 1 also, then output is, that is the next state is 0 only. So this is going to represent the next state. Now suppose for example, it has some present state is 1. So in that condition, if you see that here, this suppose Qn is here 1. Now what is going to happen? So in that case, again, you have to see the combination of this, how it is going to change. So finally, again, for the another condition, if you see that here, when D is 1, so when D is 1, clock is already 1 since we are considering positive edge trigger, and here this is the inverter output is going to be 0. So NAND gate 1 and 2. So NAND gate 1 having both input as 1 1, so output will be 0. NAND gate 2 having input as 1 and 0, so output is 1. Now we are able to predict the output of the NAND gate 3 since one of the input is 0. So Q will be here 1. Now this Q is given back here as the input, so that NAND gate 4 output is 0. So now here Q is 1, Q dash is 0. So Q is same as the what was the earlier input we have given just few instants before, that is D equal to 1. So whenever D is 1, next state is also 1. Whatever is the value, whether Qn is 0 or 1, whether present state is 0 or present state is 1, if D is given as the 1, then next state will be 1 only. Now here we have excitation table of the D flip-flop. So excitation table means we have information about Qn and Qn plus 1, which is the present state and the next state. Then on the basis of that, we are able to predict what was the input. So here, in case of D flip-flop, you know that characteristics also equation D equal to Qn plus 1. So whatever value of D is there, that is going to be available in the next state, or what is the value in the next state. On the basis of that, we can predict what was the value of D. So that's why what is the value of Qn plus 1, that D also have same value. So this is easy to remember, the excitation table of the D flip-flop. And this truth table is the same as the D latch. So where if you have D equal to 0, then how it is going to change. When D equal to 1, then how it is going to change. So since D is 0 here and it is the transparent flip-flop, so Qn plus 1 also will be 1. No, should be what? 0. And when D is 1, then Qn plus 1 should be 1. Since D is what? Transparent. That we have to keep in mind. So like this, we have discussion about D flip-flop. So here we have truth table and excitation table. These two are very important. Thank you. Thank you very much.